Good afternoon and welcome back to day 3 of the 2022 SABR Analytics Conference. I'm SABR CEO Scott Bush. We've got a great schedule lined up for the rest of the day today. During our second session, we will be bringing you research presentations from David Hyland and Jeremy Losack, along with student research presentations from Julia Wapner and Xander Schwartz, as well as a panel demonstration and deep dive of MLB Field Vision with Ben Jedlovic, Joel Feinberg, Clay Nunnally, and Sid Sethyapathy. We will wrap up the day with an encore presentation from our 2022 Diamond Dollars Case Competition winners from Tufts University. I'd like to thank our presenting sponsors, Major League Baseball and Rawlings, along with today's session sponsor, SMT, for helping make today's programming possible. Without further ado, let's get to our first research presentation of the session. Our first research presenter for this session is David Hyland. David, take it away.
Thanks, Scott. It's really my pleasure to participate today. I've thoroughly enjoyed all this talks we've seen so far, and hope to add to it. Can you see the screen share okay?
Yeah, you're good.
All right, here we go. So the paper is called Rounding Second. It's a Probabilistic Investigation, the MLB Modified Extra Innings Rule. And this is a paper that was started in 2020. When they first started at the MLB level, starting with the ghost runner at second base for extra innings. And then, of course, I wrote the paper that fall, and you know how research goes. It's been out there, and now we've had a full season. So at some level, you think, well, it's been scooped. We know, but on the other hand, I think that the methodology and in the research is interesting because it allows us to look at ways to change the game and ways to change the rule without having to run the full experiment of running seasons. So as I get into the paper, doing some background research to talk about extra innings, one of the things I came across over time, this 1984 Brewers versus White Sox, the longest game ever. There's some from long ago that ended in a tie, but 25 innings in 1984. And I think at some point they'll be posting the PowerPoints, and to get a chance, watch this video with the link. It's really fun. I mean, it's this long drawn out crazy affair. There's also one of the beautiful things about SABR, you've got this great stories about it and so on. The paper is not intended to be judgmental. It's not intended to be like, hey, we should do this or we shouldn't do this. It's more a look at, if we do start a runner at second, how many innings can we save? Or if we start a runner on first, how many innings can we save? So the focus of the paper is on the rule that it was actually done with a runner on second and nobody out. But at the end, I'll talk about, it's very easy. I've run the analysis for starting a runner on first, starting a runner on third, and so on. And we'll talk about some of those. One of the things as you get into rule changes, a lot of people get very resistant to rule changes. And like I said, as I was doing research to motivate the paper, I was just looking at World Series games. And I remember, just a couple of years ago, we had this Red Sox versus Dodgers game that went 7 hours and 20 minutes. And not that anybody's talking about doing an extra innings rule in the World Series, but 7 hours and 20 minutes. I mean, I'm a Red Sox fan. I even went to bed early on that and had to read about it in the paper. But the thing that really caught my attention and grabbed me, we tend to think about, people talk about baseball is this pure game that never changed. Well, just as you do the research, you realize it's just not true. That the game has changed, even if we still play. So I looked down at this bottom circled event. In 1916, we had a 14-inning World Series game that went 2 hours and 32 minutes. So, I mean, we realized, I mean, the game has changed. It's much longer. So why can't we experiment with rule changes and things like that? So again, not being judgmental, not the focus of the paper, but something I came across. So let's jump into the meat of the paper, the purpose, the methodology. We're trying to create a methodology. We're trying to study. If I start the last batted out on second base with no outs, how many innings are we going to save? How many bullpen arms are we going to save? How many guys are we not going to have to call up, and so on? Like I said, since the paper's written, we've got a full season with data. So at the end, I'll show some shows how the methodology worked in 2021 with actual results. The data that I use in the paper is RetroSheet. For anybody who hasn't played with RetroSheet data, we're so lucky to have so much data. I primarily in this paper use play-by-play data from 2019, although when I updated the results for 2021, I also used those as well. Certainly, I think the paper, if you're really using it to make a decision, it would be worth throwing in more seasons worth of data. Although we certainly want to think about what, probably what's most important is to make sure we're using the most current run scoring environment. So anyway, data used RetroSheet, some of the programming, inspired by the book Analyzing Baseball Data with R, Max Marshy, Jim Albert, and Ben Baumer. Wonderful book for, I saw some of the presentations last night, people talking about ways to ramp up skills. I think this book, Analyzing Baseball Data with R, you sit down and you try to replicate all that work. You're going to learn a lot of baseball and have a lot of fun in the process. So let's jump into it. We look at the actual extra inning games in 2019. There were 208 extra inning games, which is about equivalent of about 1 every 11 days for a team. So a significant event. 478 extra innings played in 2019, or the equivalent of 53 free baseball games. The Rays had the most in 2019. They played 19 extra inning games for a total of 48 extra innings. So think about it. They had to come up with 5.3 extra games worth of pitching due to extra innings. All right. So when we get down to this is the first table we're showing. We really get down to a lot of numbers on this page. I know we're not supposed to show a lot of numbers, but let me just call your attention to here's this situation. Here's what kind of drives the whole result. 21,000 innings in 2019. In 15,000 of them, the visitor scored 0 runs. And then of those, 11,000 times, the home team scored 0 runs. And so, we think about the run scoring environment in the MLB with 4.5 runs scored per game, about on average. It's not surprising that a lot of innings end up 0-0, right? So only 28% of the time do we have a different result than 0-0. The home team visiting team scoring 0 and the home team scoring 0. Notice in the run scoring environment, we've got most of the other outcomes. The team scores 1 run. 86% of the time, the home team scores a different number of runs. So if we think about if we're trying to design an extra innings rule that will end the game sooner, we're looking for variance, right? So if we create an environment where both teams score 1 run, we really haven't solved our problem. We've just we've just got some more scoring. Okay. So again, the other thing that inspired the paper is the book, Tom Tango, Michael Lichtman, and Andrew Dolphin, a great book about the conditional run probabilities. I keep it next to my King James edition. Wonderful book, recommend to everybody. And we think about one of the main results, or the big thing that they really hammer home, and I don't think they were the first, but certainly a very thorough approach to this run scoring environment. We basically think about the basic state. We think about in a run scoring environment where teams score 4.5 runs a game. A typical inning starts where we expect to score about 0.5 run per inning, or 0.53. And this is an empirical result. We can measure from the start of the inning. On average, teams score 0.53 runs. While the 24 base out states show that as soon as we go to runner on second, on average, we score 1.17 runs in an inning. So this allows us to do lots of different types of analysis. People have used it to analyze. The book uses it for all kinds of events. Should I bunt? Should I steal? Should I, so really informed, like if I go from one state to the other, how many more expected runs do I get to get? Well, that's not the whole story, because, here we're not trying to maximize runs. We're trying to score a different amount of runs than the other team. So here's the basic math of the paper. We're going to sum over run scoring. So we're going to measure, and I think that should be I equals 0 to n. So 0 runs, the probability of the visiting team scoring 0 runs times the probability that the home team scored 0 runs. We add those up and we get the probability of continuing the game. If we think about it, one of the things that's missing is a correlation term. One of our assumptions in the paper is that run scoring is independent. And so we do some statistical tests, and we basically find that run scoring is pretty much independent across innings. So we can take the probabilities, multiply them together. So think about it this way. If the visitors, the probability of scoring 0 is 70%, the probability the home team is scoring 0 is 70%, 0.7 times 0.7, we've got a 49% probability of continuing the game, right? So we can add that up for 0 runs, 1 run, 2 runs, and so on. So our probability of continuing depends on the probability of each team scoring 0, 1, 2, and so on. So we see this chart a lot, the expected probability of scoring 1 or more. So we see, our typical starting, the expected probability of scoring 1 or more runs is only 29%. But as soon as we put a runner on second, the probability of scoring 1 or more is 0.61. So we think about, we've got a 61% chance times 61% chance of continuing versus 0.39. But that's just one. We've got to look at each of the different events. So if we look at run scoring in an inning, in regular rules, I have a 71% chance of scoring 0 runs in the inning. And so I've got a 51% chance of both teams scoring 0. I've got a 15% chance of scoring 1 run, 2% chance of both scoring. So I've got 51 plus 2 plus 1. I've got a 54% chance that the game will continue under our regular rules. So we think about this 25 inning game. Basically, we're thinking about flipping the coin heads, or a little better than heads, 16 times. Once we start a runner on second, the probability of a team scoring 0 drops to 40%, and only 16% of the time will both teams score 0 runs. 10% of the time, both teams will score 1 run. So we can see that 54% of the time under regular rules, teams will score the same number of runs. That drops to 29% when we go to the modified rules. So under the modified rules, starting a runner on second, we get a lot more variance. Yeah, sometimes teams score 0, but when the visiting team scores 0, the home team is less likely to score 0. So we apply it to the actual number of innings played. We notice you're never going to eliminate any of the 10th inning because we play out the 10th inning. So in 2019, of the 208 games played, 91 games ended in the 10th. Under our methodology, we predict that 149 would now end in 10. 58 would end in 11. 42 now would end in 11. So we notice that the big change is that a lot more games end in 10. We still get some games that go 11 and 12, but there's a very low likelihood of games going on beyond 15 innings. So let's sum up the 2019 results. In 2019, we had 232 innings go past 10. So 232 extra innings beyond 10. Our methodology should reduce that. So by starting with a runner on second, we should reduce that to 83. One more thing we did, and here's where we're looking at actual. So in 2021, where the MLB continued with the rule, we would have, under this methodology, we predict that 155 games would end in the 10th inning. And then in 2021, 154 actually ended in 10. So that, is kind of interesting. We would have the methodology predicts that 33 would end in 11 and actually 46. So, is that just a sampling issue, or are there some strategies that changed? And then finally, we did see the one game that still went 16 innings. So again, a lot of this is based on average environment. You don't know what exactly was going on in that particular game. Taking it a little further, let's just look at how strategy might play out with extra innings. Under our first table, we might think about I expect with a runner on second, I expect to score 1.17. If I successfully bunt them over to third, my expected runs drops to 1. So you might say, well, maybe we don't want to bunt over because my expected run probability drops. But then if I'm the home team and I only need to score 1, my probability of scoring 1 or more goes from 61% to 65%. So it might be a good strategy, knowing that the visiting team scored 0, I increase my probability of scoring 1 by bunting over. And then the problem with it, of course, is a lot of bunts aren't successful, and we end up with an out and the runner still on second, or so on. Pretty hard to analyze that way. Like I said, I think in my intro it mentions I'm a partner with the Florence Yalls, as well as being a professor at Xavier. One of the things we did in 2020 that was really fun for our extra innings, the home team got to choose. We called it the Pelfrey rule. That was our manager at the time, Dennis Pelfrey, who's now with the manager in the Giants organization. he suggested that we extra innings, the home team chooses offense or defense. If your offense, your last batted out starts at first, if you score them, you win. If the defense gets 3 outs, they win. That was a really fun. I don't think anybody's going to argue it for the MLB because it's not. It definitely gives an advantage to the home team based on where they are in the order, what kind of pitcher they have, and so on. So I don't know anybody's arguing for that, but it was really fun. Really fun. Got games over quick. It really engaged the fans. In 2021, we went to a home run derby, complete snooze fest. By the time the L screen got brought out and everything, and it wasn't very exciting or fun. In 2021, the Frontier League is going to start with a runner on second for the 10th inning, and then go to the Pelfrey rule for the 11th. Just to wrap up, I think before we go into questions, the paper, the methodology allows for testing a new extra innings rule without having to run actual seasons. It did pretty well with the 2021 results. If we look at starting a runner on third as predicted, there's only a 3% chance of both teams scoring 0 runs, but since they both score a lot of runs, it actually continues the game longer than starting a runner on second. If you start a runner on first, the game continues more often as well. And you could look at, do you start with an out, things like that. But that kind of wraps up my 20 minutes. I'd like to open it up for questions. If I can find them.
David, you should see the Q&A button at the bottom of the Zoom module.
Okay.
Sometimes folks see it best if they stop sharing their screen.
Got it. Thank you. I think Eli asks, do you think in close games the assumption of independence might be violated? I think that's certainly possible. I don't think it would be that hard to modify the methodology, but a very interesting question. John asks, how do you think teams deploying their pitchers non-randomly skews the results? Again, I think that's another good question. Again, almost the same question, just a violation of the independent uncorrelation. Question, how long do you think an extra innings game would go if each half inning started with the bases loaded and no outs? Good question. My guess on that one is you're going to get a lot more relievers, although the three batter rule might help with that. Gary asked, would multiple ghost runners end the game more quickly? I don't think so. My gut says, it's probably the runner on second, unless we change the outs, which could certainly, adding outs would speed up the game as well. Noreen asks, would the extra innings have more of a benefit in the regular season or postseason? I would see an extra innings rule more for the regular season. I think the NHL really figured out in 2004. They came back after their strike and had the regular season 3-on-3 and shootout that I think really energized fans, got the games over quickly, and didn't end in ties. I don't think that people are necessarily arguing this for World Series and so on. I think the I think that's a little different animal. I think the regular season, I think you really want to think, and I go back and I didn't talk about this, but I actually have this story written in the paper. When we did the Pelfrey rule in 2020, I had my 11-year-old down in Lexington, and we were watching, and the game went extra innings. And I'm thinking, I got an 11-year-old, I got to get home. I've got an hour and 15-minute drive. And then I realized we were doing the Pelfrey rule where it's going to be 3 outs or a run scored. And I'm like, well, let's stay. And boy, what an exciting finish for an 11-year-old fan and myself. And we still got home in time that mom wasn't too mad at us. So, you know, when you think about some of this stuff, you can't discount the fact that you've got these young fans that you're trying to hook for life, and you know, getting to see the game finish, especially when your team wins, is particularly fun. Coach Harden asked the normalization factor, if any, was used. I'm not sure I understand the question. If you could email me that, hyland@xavier.edu. I'm sure there's a question I'm not processing right now. Michael asks, what are your thoughts on the impact of a rule change like this could have at the collegiate level? And I work with the Xavier baseball team, so this one's really particularly interesting to me. What's hard with the collegiate for me is I don't have play-by-play data. I mean, we're starting to get more play-by-play data. So the approach, the cool thing about the approach is you can build a Markov model that basically creates the 24 base out states based on assumptions about the collegiate game and the run scoring environment, and run a simulation to try it that way. So I've thought about that. I mean, if you've got good play-by-play data, you could use it for college as well. But I just, the example I think of in the college game, I was I think it was Saturday or Sunday, I was watching Georgia Tech and Virginia Tech, and it was late on Sunday, and I was excited to have collegiate baseball on. But I realized those kids were playing like in the I can't remember how many innings it went, 14 or 15 innings, I think. And I was thinking about those poor Virginia Tech kids that had to get on a bus to go back home and needed to be in class on Monday. And how if they were my students, I'd be missing them. So I think the idea of doing it at a collegiate level is wonderful. Stephen asks, is ending ties historically more prevalent in recent years? That's a great empirical question that I don't have. You know, do the 3 outcomes cause that more? That'd be a great research question. I don't have a good answer. Andrew asks, how much more of an advantage is it for the home team to know if they need 1 or multiple runs? You know, and I think that could be a good behavioral question. You know, is it nice to know I can score a 0 and still continue? Jordan asks how many pitchers were able to be saved in 2021. I think I could try it off the top of my head. So if we save 150 innings, you know, maybe 50 pitcher outings. I don't know. Good question. The flip side of that, I have a friend whose son is in AAA, and you know, they're excited about the possibility of long extra inning games and double headers because their son might get called up to the majors. So, you know, there's all kinds of competing issues on all these, and that's why we didn't set out to make it too judgmental, just to study the event. And I think, Scott, I think my time's over. What great questions. What a pleasure. Thanks to you, the SABR staff, SIS, and particularly SMT for sponsoring this part of the session.
David, thanks so much for joining us. Hopefully those that need to reach out to you see your email in the chat box there. And it's great to have research on the ghost runners, because we could see it still again this year. I guess that's still sort of up in the air. Hopefully resolved before April the 7th.